Hi everyone, thanks for liking, commenting, subscribing, sharing the videos. In this video, we'll learn about pinacol formation, which is a flagship reaction under alcohols, and this will be used in multiple other places also. And this gives a formation for ketone, right? So, what is pinacol? Let's learn first this. What is pinacol? So, pinacol is vicinal diol. Vicinal diol means basically 1,2 diol. As you can see here, next to each other position, we have OH group. So this is known as pinacol. It can be in this kind of case, or it can be, let's say, in this kind of ring structure, okay, or it can be some other structure also where we have two OH group. Let's say it can be PH, C, Me, OH, C, Me, PH, OH. That's also a vicinal diol or 1,2 diol. Now, what is the way to form pinacol? So, what is the way to form pinacol? We have to understand that. So, basically, we can take ketones and we bring magnesium amalgam in presence of H3O plus. We are doing this reaction, and this gives you directly formation of corresponding pinacol. So, what's the mechanism for this reaction? See, if you take MgHg, Mg source of Mg plus 2 electron, and we are taking one by one all these electrons to attack on these carbons. And once you attack on these carbons, can we say the bonds will break towards O minus? Hence, they will become O minus at this place. And these are radicals here, right? Radicals and O minus. And then these radicals club to form a single bond. As you can see here, this is a single bond formed after the radicals combine. And then H3O plus, which is given, will be coming and which will be providing you H plus for the further reaction. So we can say this is the source of H plus. This will go grab H plus and water is out. So at this place, what we get CH3, CH3 and OH, right? So you can just draw this structure like this as well. I hope you understood the whole process. So pinacol formation is via magnesium and Hg H3O plus. Now this is we can say this similar thing we have observed when we take Na heating and Na xylene heating. Remember, this is done in a special reaction called acetylene condensation. I'm mentioning this thing because there are a few common things, common features. This is a feature of ester reaction, but there are a few common features of this reaction which are matching with this particular reaction. Now next is what is pinacol, pinacolon. So when pinacols are treated with mineral acids, mineral acid as in let's say HCl, acid chlorides, zinc chloride or other electrophilic reagent, then they rearrange to form ketones which are called pinacolons. Okay, they rearrange to form ketones which are called pinacolons. So stable carbocation is the first priority or first criteria. For example, if I have PHCPH OH, CMeMeOH. So definitely both the options are available for us to put H plus, but which option we're going to pick? If this goes and take H plus, it forms plus charge at this place. If this goes and take H plus charge will be formed at this place. Now you take a call which plus charge is suitable option. So my answer is definitely at this place if plus charge come, it is more stable because of 2,2-phenyl group come like at this particular position as compared to 2 Me groups. So stable carbocation is the first criteria. And once you get a stable carbocation, let's say I get this carbocation PHC, PH plus CMe, Me, okay, and OH. The next step is this OH will try to push the bond so that one of the groups will migrate here and the plus charge will be taken care of. Now the next question is which will migrate. So in this question there is no difficulty because both are Me, but the problem can come when the questions have different possibilities of movement. So let us say we have option of Me movement and hydrogen movement. Remember, we always prefer hydrogen movement over and above any what you call R group movement. So H is preferred over and above R, but aryl is preferred maximum. And in aryl also there is a criteria that your aryl should be carrying a group which is pushing group. Then it will be better option than as compared to the less pushing group, and that is that is as compared to the which is a pulling group or something, right? So we can say this kind of OCH3 is a better choice for it. Okay, so which is N-acyl group we can say, and para-N-acyl to be more precisely, and this one is para-toluene. So the sequences will matter here and we have to learn these things. So this is again a very important thing I have written here and you can take note of it. Now next important thing here is migratory group should be trans to the leaving group. Now this will be more useful when you come across the questions where we have, let's say, cyclohexane kind of structure with the groups present here. Let's say OH is here, okay, and or rather OH is here and Me is here. Take this example, and then OH is here and Me is here. So the step is this OH will become H plus and the OH2 plus which is leaving and the group which is migrating, okay, they should be trans to each other. As you can see, the dihedral angle is here almost 180 degrees. So these kind of cases will be preferred, and based on that this has been explained. Now OH lost from the carbon atom, which can give us most stable carbocation. Already I have discussed this point. And RDS is formation of stable carbocation. So what is meaning of this line? Let's say we have this particular reaction. Let's talk about this reaction. So you can have two options. One option is somebody can form plus charge here and one can form plus charge here. So I'll say if you try to form plus charge at this place, let's say we say this OH attacks on H plus and it forms PH, OH, PH, Me, OH2 plus. So this is less stable, and I'll say this is not good option or correct option. The correct option is PH, CPH, this getting a plus charge and the other portion getting PH, Me, OH. That's a better choice. Why is it a better choice? Because there's a more stable carbocation. So this is a correct one, that is the wrong one or less stable one. Now based on this we can understand that when you have this kind of OH2 plus formation, from OH2 plus formation, let's say we have PH, OH2 plus, and then we have PH, MeOH, and later you are telling that fine, this will become PH, a plus charge, and PH, Me, and OH. So in this process this is an RDS, right? It's a rate mining step. So OH2 plus converting into this is a RDS. Hence we will always consider this line, that stable carbocation, how to get it. Look at this question. In this question I would say that both sides are PH, Me, so it's your choice. You can put plus anywhere. Let's say I put plus here. So if I put plus here, then once O will push electrons, as we know this will do, which group will migrate? PH will migrate. So eventually what will happen, as I have drawn the structure, both the PH and one Me will be at one carbon and this will become a ketone. Next example is you have PHH, Me. So PHH, Me, first of all, which is a stable carbocation if it comes here. So this OH should protonate H plus, that's the first thing, and this OH should be involved in migratory participation, right? So this will migrate H minus part and the answer become PHHH. Look at the PHHH group. Me remains on right side. I hope you understand these examples. Next example is Me and HH. So Me, HH plus charge should come at this place, and when it comes to pushing effect of OH group, we can say OH will be pushed and H will be migrated here. So H will come here, Me will remain, and one H will be this side. Next example is this. I hope you understand these examples. Okay, so you can pause and watch these videos if you're not finding it a little faster, but I hope you understand these things. Next example is, can you put plus charge at this place? Yes, definitely, because 6 alpha hydrogen. Whereas if you put plus charge at this place, it is less number of alpha hydrogen. So this is correct. After doing this, what we can say, this is a 4-membered ring. We can expand this ring and this O will push it. So what kind of answer we can expect? We can expect this kind of answer, C double bond O, Me. Like this. Next example is, this is a 6-membered ring and a 5-membered ring. So always remember there are two options, that 6 becomes 7, 5 remains 5. Other is 6 remains 6, 5 becomes 6. We will pick this option. So why is it so? That both are 6 is better option than one is 7 and other is 5, right? As you know, 6-membered ring are more stable than the 5-membered ring and better than 7 also. So we will go for the stability. Hence, while doing reaction, you have to be cautious which place will become plus. So which part will become plus? Can I say this can become OH2 plus, and when plus is here, this bond will break and we get a 6-membered ring, right? Similarly, this is the question here. This is a 5-membered ring and a 4-membered ring. Now apply the logic. Should I make 5-membered ring 6 and keeping 4, 4? Or should I make 5-membered ring 5 and keep 5-member 5 and 4-member become 5? So I'll prefer this option. Average good things are better than one bad and one great thing, right? So it's the same thing applicable for exams also. Let's say in one exam you get 20 on 100, and other exam you got 80 on 100, better you get 50 on each, right? So now next part is, so this kind of example will be there, both will be 5-membered ring, right? This is part 1 of this discussion. In part 2 I will cover some more examples, so please don't miss out this part 2 of this video. Okay, so please refer part 2 of this video as well. Thank you very much.